layer in our network model. So the first layer we have seen was physical, and the physical layer, the unit which we exchanged for communication here was bits. The next layer we have seen was the data link layer. And the unit was, for data link, was what? What do we exchange in the data link layer?
Frames.
Frames. And today we'll talk about the next layer, which is the network layer. Each layer is responsible for providing service to the layer above it. So the data link layer, the reason we have this layer is to provide service to the network layer, and the reason we have the network layer is to provide service to the transport layer. And the transport layer provides service to the application layer. In the application layer, we have the applications and the users that need to use the network. So far we could connect two computers together through the physical layer and the data link layer, and these two computers can exchange data just with the two layers. So why do we need the network layer then?
Connect different networks.
Okay, so that's an excellent observation. So the condition here was that we can exchange data between two adjacent computers, which means the computers are directly connected to each other with a wire or wireless, and they are in range. But if they are too far away from each other, we can no longer connect them using just these two layers. So if there are multiple hops in between the sender and the receiver, such as other computers in between, routers, printers, other devices of very large distances where they are out of wireless range, then these two layers only will not work. That's what we need the network layer for. So the network layer allows us to connect many computers together with many hops in between, and no matter where these computers are located. And in order to do that, the network layer creates something called a packet. And that is the unit at this layer. So the unit is here called packet that is being exchanged between the machines at this layer. So the network layer is concerned with getting packets from source all the way to the destination. including going through many hops or intermediate routers on the way. This is different from the data link layer, which all that it did is moves frames from one end of the wire to the other. To accomplish these goals, so in order to be able to connect machines from anywhere and with many routers in between, the network layer needs to know about the network topology, which means the geographical or physical location of all the machines that are part of the network and all the links that connect them. So the network layer must know about the topology of the network, which is geographical location of all nodes. Nodes are any machines, routers, printers, wireless devices, or anything that's connected to the network, and the links between them. So you need to know that, and also it must choose an appropriate path from the sender to the receiver. Which way are we going to deliver these packets? Because there could be many possible routes to take. there's a lot of networks from here to China that we have to go through. And some of these networks could have different parameters and configurations than the network where the packet originated from. So the network layer is the one that needs to dynamically adjust its properties as the packet travels through and adjust. So this means if one of the networks in between had a maximum transfer unit set much lower to the network where the packet was sent from, this means that the packet might be too big to pass through that network. So the network layer is the one that has to examine this property, and if the packet is too big, it's going to break it into smaller pieces so it can pass through that network. There could be many other parameters that differ, and this is the layer that has to adjust to whatever network the packet is passing through and make it to go through that network. Some design issues that we have seen on the previous slide. The network layer will provide services to the transport layer. It can provide connectionless service, which is what it mostly does in reality. But it can also provide connection-oriented service. It's possible to have connection-oriented service in this layer, but in reality, the connections are implemented in the next layer, in transport layer. In practice, theoretically, it's possible to also implement connections in this layer if we wanted to. If we have that, it will be called a virtual circuit. So if we have connection-oriented service, we will name that a virtual circuit after the telephone companies, which do that because they implement connections. If we have connectionless service, we will call that datagram in analogy with the telegram of the post office, because the post office functions very similar to what we do in the network layer when there are no connections. So these are the types of services that we can provide to the transport layer. Let's look at the store and forward packet switching.